if I told you there is one hidden process happening in your body that is making you age faster, making you hungrier when you're full, and setting the stage for diseases like cardiovascular disease, Alzheimer's, diabetes, and even cancer? This process is called chronic inflammation, a slow, smoldering fire that you can't feel, but over time is disrupting every system in your body. But to understand why it's so dangerous, we first need to understand how your immune system works, the very system designed to protect you. Because the same defenses that keep you alive during an infection, if kept turned on, can turn against you. So let's break down how your immune system is supposed to work and why chronic inflammation has become one of the most destructive forces in modern health. Now, I know that the immune system is a very complicated, intricate network of systems that are working together. And we're going to get technical. I feel like this is going to be a disclaimer for all my videos, so just expect them to be technical. And yes, there may be parts that are a little dry, maybe a lot dry, but it's so critical to have this understanding. If you stick with me, by the end of this, you are going to have a fundamental understanding of how your entire immune system works. And it's going to give you a foundation to make smarter, more informed decisions about your health, your body, and how to protect yourself from disease. Your immune system is all the things that your body does in order to protect itself from invaders and first of all, immunity starts with the physical and chemical barriers that your body has evolved. Things like mucus, like your skin, like saliva, like some. If we think of our bodies like countries, it is our borders and our patrolled ports of entry that are like these physical and chemical barriers. The second layer down from that is all of the cells of your body have evolved the ability to detect some invaders. Just like everyone in a country has some ability to spot someone behaving unusually. See something, say something. Okay, to understand how this works in the body, it's important to understand how cell signaling works. I have discussed this in a previous video on insulin resistance. So if you've seen that, feel free to skip ahead. If you haven't, stick with me here. The cells of your body have all sorts of different type of receptors. And when the cells of your body want to communicate with each other, they can release signaling molecules. The way a signaling molecule works is it binds its specific receptor on or in a cell, and like a key into a keyhole, that receptor is unlocked. When it's unlocked, it changes shape and itself becomes a key for another piece of cell machinery in the cell. That cell machinery gets unlocked, changes shape, and becomes a key for yet another piece of cell machinery. And it keeps going until a final action or actions are performed. This is called a signal cascade because the signaling molecule attaching to the receptor cascades from one guy to the next guy until the intended action is completed. Signal cascades can branch out. So one signaling molecule can have a cascade that branches out to have multiple actions that synergize, like the roots of a tree sprouting out into multiple sprouts. And what does this have to do with your cells being able to detect an invader? Most pathogens express chemical structures that are not typically found in mammals. These are common foreign structures that whole groups of pathogens have. Like all bacteria, no matter what type of bacteria, have something called glycoproteins, which mammals don't have. Now, the cells of your body have something called pattern recognition receptors. These are receptors that have evolved with the express job to recognize and bind to, key into a keyhole, these common molecular patterns or structures that are found on different types of pathogens, from bacteria to viruses to parasites. When these receptors bind an intruder, a signaling cascade is triggered. And the end actions that are performed depend on which intruder receptor was activated, as well as in what type of cell it was activated in. For example, there is a different receptor that recognizes bacteria than recognizes viruses. If the virus receptor is unlocked, a signal will be triggered, which will tell that cell to shut down its replication machinery so that that virus can't hijack that machinery to make more copies of itself. Most cells, no matter what type of intruder receptor is triggered, will release pro-inflammatory cytokines. Cytokines are factors that any cell of your body can release in order to either activate or deactivate your immune system. As the name suggests, pro-inflammatory cytokines are the ones that activate the immune system. These pro-inflammatory cytokines will first bind the neighboring cells to the one that released them in order to signal them to transduce a cascade, also shut down their machinery, for example. The same pro-inflammatory cytokines will also bind something called resident immune cells. These are immune cells that live in all of the organs and tissues of your body. And they kind of act like security guards for a gated community. They watch for suspicious behavior. And when they are signaled or triggered, they call the cops. How they do this is they also release pro-inflammatory cytokines to call more immune cells to the area, but also histamine in order to get the blood to dilate to get those factors there faster. By the way, this is exactly why in a localized infection, it feels red, hot, swollen, and inflamed, and therefore where the term inflammation comes from. So everything that has happened up until now has been localized into that micro environment. But now the first responders have been called in. These are specialized immune cells that live in your blood. When they are activated by pro-inflammatory cytokines, as well as their own intruder receptors being activated, they mount a three-pronged attack. Number one, a cascade is triggered within these immune cells that makes them generate and release reactive oxygen species. Okay, so the cells of your body, all of them or most of them, have the ability to take oxygen with nutrients like glucose and turn it into energy and carbon dioxide in a clean reaction. But the cells of your body have also evolved the ability to make this reaction messy. And when it's messy, instead of having a stable carbon dioxide created, it creates reactive oxygen species. As the name suggests, these are oxygen molecules that are unstable and they really want to react with something to become stable. It'd be kind of like if you poured acid on your arm, that acid wants to react and it would burn your arm. It's the same idea. Now, these immune cells make reactive oxygen species on purpose and release it in a localized, targeted manner in order to wound and kill pathogens that are nearby. Number two in this three-prong approach attack is they release pro-inflammatory cytokines. Yes, there's a lot of this happening that go and bind a receptor on your liver. And when they do that, they trigger the release through a cascade of C-reactive protein. You may have heard of this before, as it is something that is normally tested in your blood work. C-reactive protein then activates protein machinery that lives in your blood. This machinery, when activated, binds to the pathogen. Again, partly by recognizing those foreign pattern structures on the pathogen. And by binding the pathogen, it's like they're marking it, tagging it with an X, saying immune cells, this is the bad guy, just in case it tries to evade your immune system. This machinery even drills holes into those pathogens, causing them to explode, kind of like if you slash someone's tires. Lastly, number three, these specialized immune cells literally engulf, eat up the pathogens that have been marked, that have the X on them. Up until now, we have been talking about your innate immune system. Your immune system has two overarching arms: your innate immune system, your adaptive immune system. We've only so far talked about your innate immune system. It's like the name suggests, it's innate, intuitive to your body and your cells. It starts with your first line of defense, your skin, your mucus, your stomach acid, to those intruder receptors on almost all of the cells of your body, to those resident immune cells that act like security guards, to those first responders, those pathogen eating specialized immune cells that also trigger a chemical warfare response. It is a rapid response from seconds to hours, and it is also non-specific to the particular pathogen. What I mean by this is, let's say you are infected with coronavirus. Your innate immune system has no idea what kind of virus it's being attacked by, but it can tell bad guy from good guy because of a general pattern that virus has. It's kind of like if someone was mugging you on the street, you don't have to know their name in order to know that they're a bad guy. You can tell that by the pattern of their behavior. Now, if we go back to the analogy of your body is a country, then those specialized immune cells are like first responder cops. Once the security guards call them, they're first on the scene. They can generally tell the good guys from the bad guys, and they do their best to control the situation with the weapons at their disposal. Your innate immune cells have cool names like monocytes, macrophages, neutrophils, dendritic cells, and they all specialize a little differently in how they attack pathogens. But the general overarching way they do this is the same. It's just like a police department will have different departments. You might have patrol cops or you might have a SWAT team, but they all target bad guys. Now, if the innate immune system can't handle the situation, they call for backup. And that's where your adaptive immune system comes in. Your adaptive immune system, like the name suggests, adapts to the pathogen. It is your body's second and more specific line of defense, building on the initial response of the immune system. Because it does need time to adapt, it is slower in response, more on the order of days up to a week or two, but highly specific. If your innate immune system is like first responder cops, then your adaptive immune system is like calling in military snipers. Think of it as an escalating hostage situation. It's gone from hours into days. It's all over the news, the hostage taker's name, address, whole family history, whole life is on the news. At that point, the snipers know exactly who they're targeting. So how does this work in the body? Okay, so when you are born and developing in young age, you make a crap ton of B cells and T cells. I'm going to explain the differences later, but for now, just think of them as the same thing. In B cells and T cells, there is a part of the DNA that is like a random letter generator. B cells and T cells have special machinery that can cut and paste random strings of DNA letters together. Kind of like, in movies when a serial killer is making a ransom note and they're using magazine clippings of words or letters to make their full letter, kind of like that. This process is truly random. Each B cell and T cell has its own unique random string of DNA letters. So you have millions or trillions of unique B cells and T cells. They are some of the only cells of your body that typically have different DNA than the rest of the cells in your body. Okay, so these random letters live in a part of your DNA that tells your cells how to make antibodies. Okay, now within B cells and T cells, there is machinery that reads that code like a blueprint to build the antibody that it then displays on the surface of its B cell and T cell. Now you have millions or trillions of B cells and T cells, each displaying a different antibody. T cells are made in the thymus, whereas B cells are made in your bone marrow. That's difference number one. But the body has a problem. The letters generated are truly random, which means you may have made antibodies that can also bind your own receptors on your own cells. The cells of your body, depending on the cell, expresses different types of receptors. For instance, your muscles express the insulin receptor. In your brain, your neurons express receptors for dopamine and serotonin. So there's all sorts of different receptors, and the cell determines which receptor is on its surface. A random antibody could bind to these receptors and then trigger autoimmunity. But your body came up with a pretty clever way to overcome this. It evolved trainer cells. And these are specialized cells that pretty much express most of the receptors that your body makes. It then lets T cells and B cells float over kind of like a conveyor belt. And if any T cell or B cell binds too tightly to these specialized trainer cells, a signal cascade is triggered for them to terminate themselves. It's called apoptosis. And so anything that recognizes itself is killed. Only B cells and T cells that don't bind or barely mildly bind are allowed to go on and live in your bloodstreams, your lymph nodes, and your organs. So putting this all together, what happens when you have an infection? Your innate immune system are the first responders, and they do their best to engulf or chemically subdue the intruder. If they need backup, they recruit your adaptive immune system. They do this by traveling to the lymph nodes and presenting the chewed up pathogen on their cell surface in a receptor of sort. They're actually called antigen presenting cells, these immune cells that are literally presenting an antigen, like a invader, to your B cells and T cells. Kind of like showing your B cells and T cells a mugshot of the invader. If the B cell or T cell has a antibody that binds that intruder fragment, two things occur. Number one, signal cascade that makes rapid clones of that B cell or T cell. So you have a clone army specifically designed against that one pathogen. Number two, they become activated. For B cells, that means there is a signal that cascades that makes it release lots of its copies of its antibody that go and directly neutralize the pathogen. In general, B cells target bacteria. For T cells, although there's a few different types of T cells, the main one that we know of are called cytotoxic or killer T cells. When their antibody binds a fragment of a pathogen, its killer mode is activated. Killer T cells usually target cells that have been infected by a virus and now have parts of the virus showing on their cell surface. So when they come across an infected cell that triggers its antibody, it signals to that infected cell to self-destruct and thereby destroys it. Now, I've generalized a little bit about how the adaptive immune system works. The thing is, it is so specialized and deadly. You want to have at least two signals to activate it. Signal number one is that its antibody on a T cell or B cell binds like a key into a keyhole to a pathogen. Signal number two is usually from another immune cell telling it, yes, go ahead and activate. Just like with a military sniper, this is high stakes. Signal number one that they have the go ahead is that they have a clear shot of the hostage taker. Signal number two is they have the all clear from top brass to take the shot. And once the pathogen is gone, you still have a pool of clones of B cells and T cells. These are called memory cells, so that if you're ever infected with that same pathogen again, you have a much quicker response and immunity. This is also how vaccines work. A part fragment of the pathogen or a completely dead whole pathogen is introduced into our bodies where it's no longer harmful. It can't actually be pathogenic and hurt us, but it still triggers our immune system. Our adaptive immune system creates antibodies and memory cell clones so that you have immunity in the future if that real pathogen ever infects you. You even have immune cells that are specialized in killing cancer cells. A cancer cell, by definition, has mutated. And so sometimes what they expose to the immune system is a mutated receptor that your immune system does not recognize as self. It gets activated and tries to kill the cancer cell. Now, sometimes cancer cells have developed mutations that allow it to evade the immune system, but the immune system is still a very important aspect of cancer defense. Inflammation then is essential. Without it, infections and cancer would overwhelm us very quickly. Importantly, just as your body has pro inflammatory cytokines to activate the immune system, it also produces anti inflammatory cytokines to calm your immune system down. One of the most famous ones is IL-10, which signals stand down, everything's okay. But like any biological system, your immune system can go wrong. The adaptive immune system can start to target your own tissues, recognizing self as an intruder by mistake. And this is the root cause of autoimmune diseases like type 1 diabetes. Your adaptive immune system T cells attack your pancreas, beta cells in your pancreas that produce insulin. Rheumatoid arthritis is when your adaptive immune cells are attacking generally the cartilage in your joints, causing inflammation and severe pain. Inflammatory bowel disease, psoriasis, MS, where your immune system is attacking this protective coating around neurons in your central nervous system. Putting those aside, there is another type of very common immune response most people are living with without realizing it, and it is wreaking havoc on your body. That is chronic inflammation. Chronic inflammation is the low level activation of immune cells, as well as the low level release of pro inflammatory cytokines that, when present all the time, everywhere, disrupt the normal operation of your cells. The problem with chronic inflammation is that the job of your immune system is to disrupt and destroy. That is its job. That's its primary function. And we want it to do that when we have an invader present, but not when everything is calm and okay. It's as if every tissue, every organ in your body is trying to just do its regular job, but it can't. It is being disrupted from being able to do so. For instance, the same pro inflammatory cytokines that activate your innate immune cells on purpose produce reactive oxygen species, when always turned on, activate the same pathway in other cells of your body. Those reactive oxygen species within the cell start damaging all of the different machinery, damaging DNA. Those cells start to work suboptimally, if at all, and can accumulate enough mutations to become cancerous. It would be like if the cops took to the streets and just started tasing everyone, just started throwing tear gas everywhere or worse, and you just couldn't leave your house without being slightly assaulted. And yet there is no invader to be seen. What is so insidious about chronic inflammation is it's not like something that you can feel. It's not like when you're getting sick, you're getting the flu, you have symptoms where you can tell that you're sick, or when you have a cut on your arm and it's inflamed and you know what's causing it. It goes largely unnoticed or attributed to something else. For example, neuroinflammation, which is the inflammation of the brain, can cause depression, it can cause anxiety, it can cause brain fog, but you don't immediately suspect that it's due to chronic inflammation. In fact, the first or second step to our most deadliest diseases, those diseases that kill us the most in the world, are first a cell in the body sends out a distress signal and chronic inflammation develops. Step one in developing type 2 diabetes is fat cells get so big, not enough oxygen can get into parts of the cell. Step two is they release pro inflammatory cytokines, like an SOS signal asking for help. And those cytokines interfere with insulin signal, telling the fat cell to keep adding more fat to it. In the short term, that fat cell gets a break from having to put more fat in, but then fatty acids start to spill out into the bloodstream. And those fatty acids with those cytokines are interrupting insulin signal all over the body and eventually lead to type 2 diabetes. The initial problem is overnutrition, just too much glucose, too much fat. But the second domino is inflammation. In fact, just being chronically stressed, which triggers the activation of cortisol chronically and also leads to pro inflammatory cytokines to be released, can also cause insulin resistance, even if you're not overeating. Cardiovascular disease, specifically in the development of plaque, step one is LDL particles, which are like a protein capsule that is shuttling cholesterol and fats on the inside. These LDL particles, because of their size and shape, stick to proteins that are found in the arterial cell walls. Step two is your immune system is trying to help, so it gets activated and it's trying to engulf these LDL particles, but the cells get stuck and start to make this fatty white streak, which eventually develops into a plaque, which can completely clog or erupt and cause heart attacks and strokes. The reactive protein, which is released by the liver in response to pro inflammatory cytokines, appears to be a better indicator of developing heart disease than even LDL cholesterol. In neurodegenerative diseases, step one is something triggers chronic inflammation like insulin resistance or type 2 diabetes. Step two is the brain's resident immune cells are triggered to release pro inflammatory cytokines as well as reactive oxygen species because your brain believes it's under attack. Chronic release of pro inflammatory cytokines in your brain can impact the amount and type of neurotransmitters that you make, which can contribute to things like depression and anxiety. Coupled with the reactive oxygen species, which is damaging the neurons in your brain, is what's believed to be leading to neurodegenerative diseases like Alzheimer's and Parkinson's. As we've discussed, unresolved inflammation can lead to a microenvironment that promotes the initiation, progression, and development of tumors. Inflammation is now actually considered one of the hallmarks of cancer. Let's say you're not worried about cardiovascular disease, diabetes, neurodegenerative diseases, or cancer. Did you know that chronic inflammation can make you think you're hungry even when you're not? There are insulin receptors in your brain and other hormonal receptors that, when insulin and those hormones bind the receptors, trigger a cascade that tells those neurons that you are full. However, as we know, chronic inflammation, pro-inflammatory cytokines, that is, interfere with insulin's signal. So even though you are physically at capacity, you could not stuff more food in your stomach, you are not able to turn off that signal that you are still hungry because insulin can't cascade its message. It's like the opposite of how GLP-1 and Ozempic work. Now, you may have noticed chronic inflammation and insulin resistance, or put another way, metabolic dysregulation, are tightly linked. The one can cause the other, and vice versa. This is why, if you look at markers of insulin resistance or diabetes, like fasting blood glucose levels, or if you look at markers of chronic inflammation, like C reactive protein, these are both highly, highly linked with those deadliest diseases that we talked about: cardiovascular disease, neurodegenerative disease, cancer. These two are thought to be, if not the underlying causes of most of our chronic and deadliest diseases, hyperaccelerants of them. And I've only talked about the big gun, the big chronic diseases. Chronic inflammation also causes accelerated muscle loss, contributes to joint degeneration. It can cause immune exhaustion. Your immune system is overwhelmed from always being activated, and then you start to get constant infection. It can cause your gut to get leaky, start letting in your gut biome into your bloodstream, which thereby causes inflammation and irritable bowel syndrome. It can reduce collagen production so that your skin literally ages faster. You look older faster. So what causes chronic inflammation? The biggest culprits are, number one, overnutrition. Food that leads to obesity and especially visceral fat. Number two, poor diet, which is different, and I'll explain. Number three, inactivity. And number four, stress and poor sleep. These are the big four. As we've discussed, fat cells release pro-inflammatory cytokines, which are the first domino in a devastating snowballing impact on all the systems of your body, where chronic inflammation and insulin resistance go hand in hand. Two, poor diet, starting with refined sugars and starches. These get you in two ways. First of all, refined starches and sugars are really easy to overconsume. It's really hard to overconsume broccoli. It's really easy to overconsume candy, cake, pasta, you name it, right? So just because it's really easy to overconsume, especially because it does impact your dopamine reward system, so you want more even if you are full. This is what leads you to gain excess fat. Number two, if you are insulin resistant and getting to the point where your body can't clear glucose from your blood vessels, then glucose starts to be turned into advanced glycation end product. These are very sticky glucose chemicals that want to chemically react with everything, and they start to damage your tissues and, you guessed it, cause chronic inflammation. On top of that, processed foods already have advanced glycation end product and additives in them that by themselves activate your immune system. So even if you're eating within a healthy calorie range, not over consuming calories on processed foods alone can trigger chronic inflammation. Okay, lack of physical activity actually reduces the anti-inflammatory system that you have. So we know that when we exercise, when our muscles are contracting, they're actually releasing anti-inflammatory cytokines or inducing the release of anti-inflammatory cytokines like IL-10. Stress and sleep deprivation, we know, chronically increase cortisol levels, which thereby activates chronic inflammation, and pro-inflammatory cytokines, which thereby induces chronic inflammation. These are the major causes, but there's also any type of pollutant or irritant like smoking can cause chronic inflammation. Excess alcohol can cause chronic autoimmune diseases, can cause chronic inflammation as well. Okay, how do you know if you have chronic inflammation? Like I said before, sometimes you don't have any symptoms, or sometimes you do, but you don't correctly attribute it to chronic inflammation. Here are some things that you can look out for. If you feel tired even after a good night's sleep, if you have brain fog, if you have anxiety that you can't attribute to anything in particular, or if you have depression, if you have any joint pain or stiffness that isn't tied to a specific injury, sometimes GI distress, diarrhea, bloating, constipation, acid reflux. If you have difficulty losing weight, especially around the midsection. If you have skin problems that are constant, like acne or flare ups like eczema, or maybe you're just having a lot of frequent infection. These are all signs that it could be chronic inflammation. It could be other things, but it puts it in the realm of possibility. To be more sure, you want to look at your blood work. There is your C-reactive protein, particularly the high sensitive C-reactive protein test, or HSCRP. Persistent values in the 2 to 3 milligrams per liter without infection suggest chronic inflammation. If you have a DEXA scan, you can now get them commercially. They're about $100, but they're really, really great. They tell you so much about your body. One of the things they tell you is how much visceral fat you have sat around your organs, particularly your midsection, versus subcutaneous fat, which is just fat under your skin, which is generally thought to be healthier. If you do get a DEXA scan, you want to have less than 2.2 pounds of visceral fat. How do we reduce chronic inflammation? I'm going to give you the best ways to do it, but I'm also going to give you something I call cheat codes. I understand that changing behavior is so incredibly difficult to do. And therefore, these cheat codes are entryway, low hanging fruit, things that you can do. First of all, we're going to optimize the diet. What you eat directly impacts the inflammation in your body. First, we're going to reduce inflammatory foods, cutting back on refined sugars like white bread, pasta, candy, dessert, sugary drinks, fried foods, processed foods, trans fats are found in margarine. We're going to increase anti-inflammatory foods. We're going to incorporate foods rich in antioxidants and polyphenols, like leafy greens, spinach, kale, fruits, berries are great, and olive oil. Spices like turmeric or cumin and ginger are also powerful anti-inflammatory agents. High intake of antioxidants and polyphenols help neutralize reactive oxygen species that are produced during an inflammatory response. Foods high in omega-3s, like fatty fish, think salmon, seeds, and nuts, like walnuts and flaxseed, also have anti-inflammatory effects, but in a different way. Omega-3s in the body are converted into signaling molecules that turn off the release of pro-inflammatory cytokines while turning on the release of anti-inflammatory cytokines. 1-2 punch. Okay, so what are some cheat code item things that you can do? First of all, if you add sugar to your tea or coffee, switch it out for stevia. Stevia doesn't ever get into your bloodstream. It just goes straight to your colon. Also, if you drink sodas, make sure they are diet soda. Another cheat code or low hanging fruit everyone can do is to take supplements for vitamin D magnesium, and omega-3s. It's rare that people like to eat a lot of salmon, so we probably aren't getting enough omega-3s. 95% of Americans don't get sufficient amounts of vitamin D. 40 to 50% are deficient in magnesium. Magnesium is required by the body to take vitamin D and make it into a hormone that has anti-inflammatory effects in the body. In fact, low levels of vitamin D, omega-3s, and magnesium have all been highly linked with chronic inflammation. Another kind of low-hanging fruit thing that you can try if you really don't want to change your diet is something called intermittent fasting. Most people find it pretty easy to skip breakfast and start their first meal at lunch. This, in theory, if you currently eat breakfast, cuts out 300 to 700 calories from your daily intake. This alone will help you to decrease your overall weight, some of which will come from fat, which has been shown to reduce chronic inflammation. Okay, managing stress. We already talked about it. Chronic stress can elevate pro-inflammatory cytokines. Research has shown that doing a practice like yoga or meditation can decrease pro-inflammatory cytokines as well as chronic inflammation. Regular physical activity can do the same thing, as we discussed. Find time for relaxation. Walk outside in nature. Have hobbies that calm you down. Cheat code thing that you can try. This is a type of breath work that you can do. Pretty much every type of breath work kind of helps calm you down, but it is called a physiological sigh. It's breathe in as much as you can, and a little more, and slowly on the way out, and that will instantly calm you down. Try to do that once a day. It takes a couple of seconds, and anytime you feel especially stressed. Okay, number 3, get good quality sleep. I feel like in a lot of ways, this is the easiest one to do for most people. What do I mean by that? Okay, you spend 1/3 of your life asleep. If there is anything to save up for or not to penny pinch on, it is the quality of your bed, your sheets, your pillows, and everything that's going to help you fall asleep. Invest in a good bed. There are now bed toppers that you can purchase that help you set the temperature of your bed. This is really important because our body temperature actually drops 1 to 2 degrees in order for us to fall asleep. So by being able to set and maintain a temperature of your bed, you're going to get better quality sleep. If you want to go the extra mile here, you can get air filtration systems for your bedroom that pulls out carbon dioxide. You can also find a pleasant scent that you like from essential oils. You don't want to use candles. And when you travel, you can take that scent with you, and that will help recreate your own environment when you are on your travels and help you sleep better as well. Exercise. Physical activity is one of the most potent ways to have an anti-inflammatory response, independent of weight loss, meaning people that exercise and did not lose any weight significantly decrease chronic inflammation in their bodies. Here, you want to try to get 2 strength training days in and 150 minutes of moderate aerobic exercise or 75 minutes of vigorous aerobic exercise per week. Cheat code coming at you. If you really do not like exercising, what you can do is after every meal you eat, try to go for just a 10-minute walk. That has been shown to blunt your glucose blood sugar spike. That's going to have dramatic impacts on reducing your chronic inflammation. Also, if you really don't like exercising, or even if you do like exercising and you have access to a sauna or a hot tub, or even a really hot bath or a really long hot shower, you can use those 3 to 4 times a week. What they seem to do is 1, mimic exercise by increasing your heart rate, getting your blood flowing, but 2, they activate something called heat shock proteins in your cells which are responsible for breaking down damaged cell machinery and building it back up nice, brand new, and optimized. Number 5, achieve a healthy weight. Excess fat, especially visceral fat around the organs, as we discussed, is a major, major driver of chronic inflammation and chronic disease in general. You can do this by employing the strategies that we spoke about before, everything from intermittent fast, exercising, doing your walks, cutting out especially inflammatory foods, or by generally calorically restricting your diet. And combining that with exercise is going to be even more powerful. Okay, and there you have it. Here's the bottom line. Chronic inflammation isn't just a background process. It is a hidden driver of some of our deadliest diseases. It silently accelerates aging, disrupts your metabolism, hijacks your hunger signals, and damages your tissues long before you feel sick. The good news is it's not inevitable. Your immune system was built to protect you, not sabotage you. Making small, strategic changes in your food, your movement, your stress, your sleep, you can quiet that smoldering fire and return your body to balance. Think of it this way. Every anti-inflammatory decision that you make, whether it's swapping out processed food, getting an extra hour of sleep, moving your body, or simply taking a moment to breathe, it is like telling your immune system, stand down, everything is calm. And when your immune system is calm, you are calmer as well. Your energy, mood, focus, and long-term health will improve. Chronic inflammation might be the hidden accelerant of modern disease, but it's also one of the most powerful levers that you can pull to protect your future. So take one step, start with one change, and you'll already be rewriting the story of your health. Thank you so much for joining, for sticking with it. If you've made it to the end of this video, I thank you. If you enjoyed this content, please go ahead and subscribe and hit the bell. That way it will tell you when a new video comes out. And if you found this helpful or think someone else will find it helpful, please do share.